Good morning, I'm Tom Gaschler and I'm here in McCook, Nebraska. Brock Rogers, Doran, McCollam, Wes McCollam and myself went out and looked at a wheat field that had been planted last fall at a rate of 1.2 million seeds per acre. This was planted across both the dryland corner and the irrigated pivot. When we drove up to the field and we were still about 100 yards away, you could definitely see the difference between the irrigated and the dryland, because the irrigated was lighter colored while the dryland looked very thick, very lush, the way the wheat should look. A lot of things have changed in the past 2 weeks since our last YouTube video. We received 1 to 2 inches of rainfall across the area. And when we took the penetrometer reading out on both the dryland and the irrigated, what we found was that the penetrometer read 200 pounds per square inch or less in both the dryland and the irrigated, down to about 15 inches. It then read 300 pounds per square inch and higher from 15 inches to 27 inches, and we couldn't go any deeper than 27 inches. The nutrient levels on this field that I had talked about earlier shows that we have a deficiency of nitrogen, phosphorus, and sulfur, and this was not only true in the soil samples taken last fall, but also the soil samples taken this spring. In addition, it's also showing up in the tissue samples that we took this past week.
This field we're looking at today, Viper pivot that was in soybeans last year, and the dryland corners were chem followed. When we seeded this, we planted right through the dryland corners and also through the pivot. Seeding rate was at 1.2 million seeds per acre. The stand counts now this spring, on the irrigated we have 766,000 plants per acre, and the dryland has 1.15 million plants per acre. So on the irrigated versus the dryland, we actually somewhere along the line lost 389,000 plants. What we're trying to do is decide why on these soybean pivots we're actually having a hard time establishing a good stand. We talked to Dr. Mears up at the Simplot meeting. He thinks there's a possibility that it's low oxygen in the soils that's could be causing some of those problems. On this field, I think we also run into some other things. We were very short on nitrogen and phosphorus both, and when those plants first came, or first were germinated, the little plants I don't think were able to take up any nitrogen and phosphorus due to, I think, a real good chance the microbes were tying up what nitrogen was actually in the soil at that time. We need that nitrogen and phosphorus when that little plant first starts to make a viable plant. It has to be able to take up nitrogen and phosphorus at that time. Also, we're going to discuss today about counting tillers. When we scout fields, we find plants per foot a row, and then we count tillers and we adjust it to plants per square yard. Today we're just going to address counting tillers. You dig the whole plant, and I like to find the largest, what's the largest, healthiest tiller on the deal will be, on the whole plant will be your primary tiller, and we count every the primary tiller and every secondary tiller that has at least 2 leaves on it. These plants today, off of these 2 fields, the irrigated was averaging 8 to 9 tillers, the dryland was averaging 8 to 10 tillers. This is out of the irrigated. Primary tiller would be be 1, 2, 3, 4, 5, 6, and a 7th. There'd be 7 tillers is what there'd be. We're still not to the joint stage. It'll continue to tiller until it joints, and then it can no longer tiller anymore. So, and we're on these, we're probably 2.5 weeks away from joint stage. Okay.